Hello everyone, today we are focusing on SURDS. Let's first start working with SURDS, with square roots rather. If you have something like this, please note that for this thing to be real, the one that I'm circling in green, for it to be real, and it simply means that whatever that is inside the square root has to be greater or equal to 0. Are we together? And the square root cannot be equal to something that is negative. So that means b as well must be greater or equal to 0, because there's no value of a that you can put under a square root and get something which is negative. That's why what's on the right hand side of the square root as well should always be greater or equal to 0. Are you together? That's the reason why sometimes whenever you solve for x, let's say for argument's sake, let me check one of the equations here that I have set. If you have something like this, for us to continue, we must write our restrictions here. This thing which is inside here, for this entire thing to be real, you must have 2x minus 9 being greater or equal to 0. All right, together. So that means we must create our restriction. Let me write it on the left hand side. That means we must have 2x minus 9 greater or equal to 0. That means 2x should be greater or equal to 9, and x is greater than 9 over 2. Are you together? And then whatever that is on the right hand side should also be positive, because there's nothing that you put under a square root and get a negative value. So even this thing which is on the right hand side should be greater or equal to 0. That means x should be greater or equal to a positive 6. Before we continue, we must consolidate our restriction. Are you together? You must have a final solution of these two restrictions. We have 9 over 2 and 6. They are both okay. Don't have to. We must represent these answers on the number line. It goes here. X is greater or equal to 6. It's there. So this is where they overlap. That means the final restriction should be x is greater than 6. So whatever solution that I will get when I solve this equation, I will take it if and only if x is greater or equal to 6. How so? Let's just solve this thing. We have 2x minus 9, x minus 6. For me to remove this, the surd, I must square both sides. Right, together, then I'll be left with 2x minus 9, x squared minus 12x plus 36. Right, together, then I must put everything to the standard form. We'll have x squared minus 14x plus 45 is equal to 0. I just took these two things to the other side, né? And obviously whenever they jump the equal sign, they will change their signs. So I have x factors of 45, that's when I add will give me 14. I'll have 9 plus 5. Then x is 9 or x is 5. Immediately I know that this one won't be applicable. X is equal to 9 only. Right, together. Why? Because I did make my restriction. I said I'll only take the x value which is greater or equal to 6. Right, together. So this will be my only equation. if you want to, you can just check on both sides. Substitute if you have 2x minus 9, x minus 6 here. You can substitute both the x values. You can start by substituting 9 whenever you see x. So that means here you put 9 and here you put 9. When doing that, if the left hand side is equal to the right hand side, therefore that solution holds. And in this case, I know that whenever you substitute 9, the left hand side will be equal to the right hand side, so this solution will hold. But if you substitute a 5, the left hand side will not be equal to the right hand side. That's why we say that solution of x is equal to 5 is not applicable. So it's important, guys, to know your restrictions whenever you deal with SURDS. We're together. So today I didn't want to focus more on solving equations because I did that on lesson 1 and 2. I did everything, solving equation with sets, fractions, brackets. Please go to the first lessons and then you learn more, even how to factorize there. Today I just wanted to show you how to simplify sets. Let's start with square roots. Square roots right together. If you have a number like this, maybe your number is a, the first thing you need to do, if let me write here, if a is not a prime number or a perfect square, if a is not a prime number or a perfect square, all you need to do, let me write in red, all you need to do, you must break down this value of a into a prime number and a perfect square. Are we together? How so? Let's say I have the square root of 18, for example. The square root of 18. I'm supposed to solve this without a use of any calculator. Are we together? What I can do is to say, okay, I know I can write 18 as 9 multiplied by 2. 9 is a perfect square because I can find the square root of 9. 2 is a prime factor because there are no other multiples of 2 rather than 1 and 2. Are we together? So this is how you break down a number into a perfect square and a prime factor. So I know, according to this rule, please go to lesson number 5, whereby I teach about exponents. There's a rule that says if you have a, b multiplying, you can say the square root of b times the square root of a. I'll do the same thing here. I'll just say the square root of 9 multiplied by the square root of 2. I know for a fact that the square root of 9 is what? Is 3. And this one is 2. The calculator will just move from here, going straight there. Then you will miss understanding the mathematical operations that happen within the calculator. That's why I strongly not advise using a calculator. Are we together? So whenever you deal with SURDS, you must always break down your numbers into prime factors and perfect squares. Are we together? In this case, we have the square root of 3 multiplied by the square root of 48 minus 3 and the square root of 75 plus 2 and the square root of 108. It's simple, okay guys, it's simple. There's a square root of 3. You can break down these things into prime factors and perfect squares. How so? I know that 48 can be broken down into 16 multiplied by 3. 75 is 25 multiplied by 3. 108 is 36 multiplied by 3. Alright, together. 36 multiplied by 3. Here I'll have a 3, and then here I'll have square root of 16 multiplied by the square root of 3 minus 3, square root of 5 multiplied by the square root of 3 plus 2 square root of 36 multiplied by the square root of 3. I still have a 3 outside here. I know that the square root of 16 is 4 multiplied by the square root of 3, and the square root of 25 is 5 multiplied by the square root of 3. The square root of 36 is 6 multiplied by the square root of 3. Right, together. I still have the square root of 3 outside. Then I have 4 square root of 3 minus 15, the square root of 3 plus 12 and the square root of 3. Are we together? So here in this case, if you don't see clearly, guys, because I can just say the square root 4 multiplied by root 3 plus 12 and root 3, it's 16 root 3 minus 15 root 3, then I'll get root 3. But all I'll do is just to make things more simpler. When I get here, I'll just say let square root of 3 to be equal to k. So therefore, I'll have k multiplied by 4k minus 15k plus 12k. This thing will be k. Inside the bracket, I'll have 4k plus 12k. I'll get 16k. 16k minus 15k is just k. So what do I have? I'll have k squared. But what is k? K is the square root of 3. If you square something that is a square root, the square root and the square will cancel one another, and I'll be left with 3. Alright, together. So the first thing you do, guys, whenever you're dealing with square roots, please break down the number inside the square root into a prime factor and a perfect square. Are you together? Let's do the second one. Let's do the second one. The second one, I have 75 plus 48 all over 12. Nah? Same thing applies. Break down these two things into prime factors and perfect squares. $75 can be written as 25 multiplied by 5. 48. No, not multiplied by 5, rather. It's 75 multiplied by 3. 48 is 16 multiplied by 3. 12 is 4 multiplied by 3. $12 is equal to 4 multiplied by 3. I know that I'll have the square root of 25 multiplied by the square root of 3 plus square root of 16 multiplied by the square root of 3 all over the square root of 4 multiplied by the square root of 3. And then here, what will I have? The square root of 5 is 5. And then I still have a root 3 multiplying 5, and then I'll have 4 multiplying root 3 all over 2 multiplying root 3. and then I'll have 4 plus 5, which is 9 root 3 over 2 root 3 all together. Then these two things will cancel one another because they are dividing, and then I'll be left with 9 over 2. Whenever you are given things like this, you'll be asked to simplify without using a calculator. All together. Okay, now let's have 2 over root 3 multiplied by 12, 2 times, okay, 9 over root 3 minus the square root of 48. Same thing applies, guys. If the number inside the square root is not a prime factor or a perfect square, you must break down that number. So here I'll have 2 over root 3 multiplied by 2. 12 I can write it as 4 multiplied by root 3 plus 9 over root 3 minus what's 48, which is 16 multiplied by root 3. 2 over root 3, this side I'll get 2 multiplied by 2 root 3 plus 9 over root 3 minus 4 root 3. 2 over root 3. These two things will subtract one another. These two will subtract one another because 2 times 2 is 4 root 3 minus another 4 root 3. They'll just subtract one another. Then inside I'll be left with 9 over root 3. Whenever you're multiplying numbers, numerators multiply one another and denominators multiply one another. So I'll have 18 over root 3 times root 3. This thing is the same as 18 over 3. And it's over 3 because please remember that, let me write this in green. Root 3 times root 3 can be written as 3 to the 1 over 2 multiplied by 3 to the 1 over 2 all together. If you're multiplying bases that are the same, you just need to add the exponents. So it will be 3. 1 over 2 plus 1 over 2 is just 1. That's why I have a 3 there. All together. So now I have 18 over 3. My final answer is 6. Okay, let's see. Now we have 2 multiplied by 18 minus 32 all over the square root of 8 plus 2 plus the square root of 2, no? Okay. Here, 18 can be written as 9 multiplied by 2. 32 can be written as 16 multiplied by 2. And then 8 can be written as 4 multiplied by 2. This one I'm leaving because 2, it is a prime factor. So this is 2 square root of 9 multiplied by the square root of 2 minus 16 times the square root of 2 over 4 times the square root of 2, like this, nah? Here I have 2 times 3 multiplied by the square root of 2, 4 times the square root of 2, 2 by 2, and then I'll have 6 multiplied by the square root of 2 minus 4 multiplied by the square root of 2. There at the bottom I have 2 root 2 plus 1 root 2, which is 3 root 2. At the top I'll have 2. Made a mistake there. Okay, then now these two will cancel one another since they are dividing. So my final answer will be 2 over 3. Sometimes, guys, it's not that easy. Sometimes you have to rationalize your denominator. Let me show you how to rationalize a denominator. Rationalize a denominator. If you have 2 over root 2 as a solution in maths, you must never leave your answer having a denominator with a radical sign. Alright, together. So in this case, what you need to do is to multiply the top and bottom by what you want to remove. I want to remove this from the denominator, so I'll multiply the top and bottom by it. So my answer will be 2 multiplied by root 2. Root 2 times root 2, I'll get a 2, and then my final answer will be just the square root of 2. Are we together? Another one, if I have (10 over root 5), still do the same thing. I don't want to have a set on the denominator as my final answer. That means I must rationalize my denominator. Rationalizing a number in simple terms are just removing the set at the denominator. All together. So I'll just multiply the top and bottom by the square root of 5. Then what would I get? I'll get 10 root 5 all over what? The square root of 5 times the square root of 5 will give me 5. And then 10 divided by 5 is 2 root 5. If you punch your calculator, if you punch this thing alone on your calculator, it will get you here straight away. But using a calculator will make you miss the mathematical operations that you need to understand. Okay. Sometimes you'll have more than one term on your denominator. Let's say you have 1 over square root of 2 plus 1. You must not have a radical sign on your denominator. Are you together? So what do you need to do? Multiply by the top and bottom by the same thing. Okay, since we have two terms, that means we must just create a difference of two squares. You have root 2 and 1, root 2 and 1. Are you together? Let me write properly. Root 2. Since here I have plus, that means I'll have a minus here and here. Are you together? Therefore, at the denominator, I'll have the square root of 2 minus 1 divided by. If you have a square root, if you have a difference of two squares rather, the first terms will multiply and then you'll have 2. The second terms will multiply, you'll have 1. Then you just put a minus in between because it's a minus because we're dealing with the difference of two squares. 2 minus 1 is 1. So our final answer is root 2 minus 1. Are you together? So whenever you rationalize your denominator, if you have more than one term, that's what you need to do. Please pause the video and rationalize this. Rationalize this. Okay. I'm assuming that you did this. you set the square root of 3 plus 2, square root of 3 plus 2, and then what do you have? You have 2 multiplied by the square root of 3 plus 4, because 2 times 2 is 4. Alright, together. On the other side, what do we have? We have 3 and 4, because 2 times 2 is 4, right? But root 3 times root 3 is just 3. So, and then keep a minus there, and then you'll have 2 root 3 plus 4 divided by negative 1. This thing the same as negative 2 root 3 minus 4. Are we together? That's how you deal with SURDS whenever you rationalize the numbers, because you don't want to have SURDS at the denominator. Sometimes you won't have square roots. For example, g here has cube roots. Are you together? So g, this is so dumb. Okay, if 3 multiplied by 4 cube root of 16. There's nothing interesting about this thing. Okay, but let's hope you learn something. Okay, here you can write this thing. Remember that from lesson 5, the exponents video, I said to you the root of your exponent of the denominator of your exponent is always the root of your number. So this is the cube root of 4 squared. Are you together? Here I'm adding two things that are the same. It's 2 times the cube root of 16. 3 multiplied by the cube root of 16 all over 2 multiplied by the cube root of 16. These two will cancel one another, and then I'll have 3 over 2 as my final answer. Okay. Sometimes you are given situations like this. Maybe you are told that given that p is equal to the square root of 5 over x plus 2, are you together? Then you ask the question number 1, for which values of p for which values of x will p be a real number? Okay, here you're just supposed to solve the inequality. They want the values of x for which 5 over x plus 2 is greater than 0. This thing will be real if and only if what's inside the bracket is positive. If it's not positive, that means this thing is not real. Are you together? So here there's only one critical value there. Okay, but I want you to see this thing make sense into it. Nah? If you are dividing two things, the first one and the bottom one, and the answer is positive, it simply means that those two things have the same sign. Are you together? I know the sign of the numerator is positive because 5 is a positive number. Are you together? So this thing simply means that even my denominator has to be positive. So what will I do? I'll just say, let me write with green, x plus 2 is greater than 0. Please note that I no longer put equal to 0 here because I don't want to have 0 on the denominator. Are you together? So because if I have 0 on the denominator, my entire thing will be undefined. So since I don't want to have 0 on the denominator, I will never put the equal sign there. I'll never put this guy. Are you together? So I'll just have x is greater than 2. So for p to be real, that means x should be greater than a negative 2. Excuse me. X should be greater than a negative 2. Are you together? But now, let's say we are asked that for which values of x will p be non-real? Question number 2. For which values of x will p be non-real? Will p be non-real, ne? Will p be non-real? Okay, p will be non-real if whatever that's inside the square root, this guy, is negative. Are you together? So what will I do? I'll just say I'll just say 5. Let me write with a different color. 5 all over x plus 2 is less than 0. Are you together? But apply sense into this thing. If you divide two terms and you get a negative answer, it simply means those two terms had different signs. One was positive and the other was negative. I know for a fact that 5 is positive because 5 is a positive number. It simply means that my denominator is the one which is less than 0. So if I'll have anything any number less than 2, less than a negative 2 rather, any number less than a negative 2, my p will be non-real if x is anything less than 2. Are you together? So all you need to know that for anything for p to be real, firstly, what's inside the square root needs to be positive. Are you together? But for p to be non-real, what's inside the square root needs to be negative. Are you together? But for p to be undefined, our denominator needs to be 0. Question number 3, you'll be asked that for which values of p will, for which values of x rather, will p be undefined? All you need to do is to just take that denominator of x plus 2, make it to be equal to 0. If x is equal to a negative 2, p will be undefined. Are you together? I'm checking for something. No, I don't have these things here. Okay guys, please stay tuned for more videos. Like, share, comment, follow. Don't forget to subscribe. and hit the notification bell. Thank you.